So the assignment model. So the assignment model, it concerns to what happens to the effectiveness function when we associate each number of the origin with each number of the with each number of the same number of the destination. So we had it is not a definition, but actually to understand it, you can remember we are going, or we are concerned about the effectiveness function, or particularly we can say we are concerned about how the objective, about the behavior of objective function when we associate each source to each destination, right? So here what we are going to do, we now particularly we are going to what we are going to do is, suppose I have a factory ABC and I have the works warehouses 1, 2, 3. So what I'm going to do here is, now the production that is happening at the factory A, I'll be linking it to only one warehouse. I won't be supplying all my units to all the different warehouses, right? So I won't be supplying the units from factory A to warehouse number 1, 2, and 3. I'll be supplying these units of factory A either to warehouse 1, either to warehouse 2, or either to warehouse 3. Right? So that is the difference between here the transportation and the assignment. Here we are not going to split the resources, or we are not going to split the units. For example, if my factory is producing 165 units, so I'm not going to split my resource. I'm not going to supply 150 to one of the warehouse and 15 to one of the other warehouse. So here it is a linkage of factory to the linkage of a warehouse, or a linkage of the destination. Now, when I say this, when I'm talking in terms of a factory and warehouse, that it doesn't mean that it is restricted to the use of the assignment model. Is restricted to these terminologies only. For example, I can give an example. If we have HOD at our civil engineering department, and he has to allocate a task to every of the faculty. Right, so we have 17 faculties here, and he has 17 number of tasks, and each faculty is going to take each faculty is going to take, or each faculty is going to get only one task, and the effectiveness of doing the task of that a particular task is known to the HOD. For example, I will require 10 minutes to do a certain certain task, while some other faculty may require 15 minutes for the same task. So all this data is with HOD sir, and according to that particular data, he is going to allocate only one task to each of the faculty. Right? So how you'll be deciding that? How if there are 17 faculties, you imagine there are 17 factorial 17 factorial combinations that he'll have to think of. Right? So 17 factorial is a huge number. If I'm thinking of only 10 factorial, so that particular number, last time we have seen it, but now it is only if I have only 10 faculties and 10 tasks, and each faculty is to get only one task, there are 10 factorial 10 factorial combinations that a person can do, and 10 factorial, the value is like around 32 lakhs. So now how he'll be testing each of this particular 32 lakh combination, and how he'll be assigning that task. So hence there is some need of some mathematical concept or a mathematical model that will be helping him, and to allocate the work, and that work will be allocated in much lesser time, and also the effectiveness of that particular objective function. That is, if he is trying to maximize the the effectiveness, so he'll be dealing with the maximization function. If it's desiring, the HOD sir is desiring to not he's not desiring to increase the effectiveness but to decrease the time. So likewise also he can allocate the task, right? So if I have to tell, if I'm known to do a particular task, in a more in a good manner. I'm not talking in terms of time here. The task will be completed. So each of the person will going to do a task, right? But a particular person will do it. He'll be doing it in a more. It will presenting it in a good fashion. He'll be doing it in a good fashion. He'll be doing with all accurate things. So all, if that is to be considered, then the answer will be different. If the time is the factor that is to be considered, then the then the answer will be different. So here there is the behavior of your objective function is very, very important. So what is your objective function? Depending upon that, the answer will change. So I'm hoping that you have understood, right? So assignment model is assigning of one source to one destination, or assigning of one task to one person. So likewise, you can have different application of this assignment model, and you can explore around this. But we are going to see it into a very into the respect of our syllabus. So now what here we can know what I have told you here. So each resource or or a facility or a origin is to be associated with only and only one job, right? So each of the resource or a facility or a origin is to be particularly associated with only one job. So job may seem some ambiguous, so we can say a destination, right? So each of the resource or facility or origin is to be associated with one and only one destination in such a manner that it will be in such a manner that it will satisfy the objective function, right? So objective function is it is playing a very, very important role in this particular case. Here we'll have to particularly think that, or we'll have to keep in mind that resources are not divisible. You can say divisible among the destinations. So this is very, very important, right? So the resources are not divisible among the destinations. So you can't say that the faculty, faculty will only get a one single task. He is not going to get two tasks because he is very efficient, right? So every faculty, depending upon the capability, is going to get only one task. If the faculty is having more capability, there are no chances that he will be given two tasks, right? So now particularly we can say we can reframe this assignment model to a very very sophisticated problem statement. So we can say that given n facilities and n jobs, and given the effectiveness of each facility for each job, the problem is to assign each facility to one and only one job, so as to optimize the given objective function, or you can even write the given objective function or even the given objective. So this is very, very important. Here a lot of things will get clear. You can say that this is the explanation of your assignment model. So what is happening, given n facilities and n jobs. So here you can see, I'm not use the terminologies m and n. It is only n. Why? Because here the number of tasks is going to equal to the number of the faculties, right? Or the number of facilities is equal to the number of jobs. So here we have n jobs and n facilities. So the number is going to the number of each of the jobs and the facilities is going to remain same. And given the effectiveness of each facility for each job, so I'm having then extra data that how much in terms of time or in terms of other effectiveness, how each facility is working, or each facility is related with each job. So for example, if there is any faculty A is taking 10 minutes to do a particular job, and a faculty B is taking 15 minutes to do the same amount, same task. So what is that? So that is the effectiveness of the faculty with that particular job. So now we are going to have some extra information, that is each facility, the effectiveness of the each facility for each job for the problem to be assigned is known to us, and then only we can solve the problem. And what is the problem here? The problem here is to assign each facility to only one job, so that we optimize the given objective function. So this is very, very, very important here, right? So now if I have to draw a matrix representing this particular thing, so I can draw it very simple, in a very simple format. Here I don't have to worry much, because here it is not as of your transportation matrix. So here we have 1, 2, let's say we have n we can say jobs here, and we have 1, 2 and n facilities here, till n facilities here, right? So we know that the effectiveness of each facility with each job is known to us, and we can represent it as C11, C12, C1n, right? So facility 2 with respect to facility 2 with respect to all jobs and its effectivity is known. So C21, C22, C2n, right? Similarly for facility this we have CN1, it is not N1. We can put a dash here, because we can't write, we don't have any particular here. So nextly it is a CN1, CN2, right, and CNN here, right? So here supply, we can say, so supply is what? Supply is only particularly it will be 1, 1, 1 and 1, and demand will be only also 1. Demand will also be 1, 1, 1 and 1. So I think you understand, because we are not going to split the resources. We are just going to assign one facility to one job, right? So here we do not know, we do not need splitting of the the supply and the demand. So here you have always particularly if you see here, particularly here I'm writing my supply as 1, 1, 1, 1, and demand is given as 1, 1, 1 and 1. So you should understand this is just the representation of representation of your assignment problem. So now here what is going to if you have to justify here, so this particular table represent the assignment of n facilities to n jobs. So here Cij, that is all these factors, these are called as Cij. So here Cij is the cost of assigning ith facility to jth job, and Xij represents the assignment of ith facility to jth job, right? So the values of Xij across all these cells will remain what? It is going to remain same 1, right? Cij values are going to change because the effectiveness of each facility for each job is going to be different. But the value of Xij across all these cells, for all the cells is remain, or you can say the value of Xij is going to remain 1 only, irrespective of the cell. So otherwise, particularly the assignment model, but the concept wise. This two are something different. So in morning we have seen one matrix, right? 1, 2, 3, 4. I'll be coming to that point so that there will be a continuity that we can maintain in this lecture. So 1, 2, and here we had a supply 1, 1, 1, 1. Here we had facilities where 1, 2, 3. Sorry, and here these were, we can say, jobs, right? So C11, C12, and C1n, C21, C22, C2n, and lastly here we can say N1, N2, CNN. Here demand 1, 1, and 1, right? So this was the matrix that we have seen in the morning. Now what this matrix tells us is that the facilities will have only the supply that is there, it was only 1, and the demand, if you see, the demand is also 1, right? So in each column there will be only one cell that will be occupied, and in every column there will be only one cell that will be occupied. So I'm hoping that you have understanding. In every row, right, every row there will be only one cell that will be occupied, as we cannot as the supply, the resources are not divisible, or we can't split these resources that we have. So no, there will be only one cell in each row and each column that will be allocated, right? All other cells will be empty, right? So now this is a very important thing that you need to understand. So now what we can see now, again, one more thing that we will have to understand here in assignment model is that it is always n by n matrix. It is never m by n matrix, or if it is m by n matrix, you will have to convert it into n by n matrix, right? Either way, it is going to be n by n matrix, and then only we are going to use the assignment model for this, right? So here what we had, Cij is cost of assigning ith facility to jth job, right? So this is your Cij, right? And again your Xij is what? Xij is, Xij represents the assignment of ith facility to jth job, right? And always remember your Xij, always remember your Xij value will be, if there is an allocation, then it will be 1. If in a cell, for, I can write here, so for allocated cells, it will be always 1, and for Xij will be equal to 0, where we are not going to do any allocation, right? This is to be remembered. It is very important. Xij is equal to 1 because we have supply as 1 and demand as 1. We cannot split our resources. So either the value will be 1 or it will be 0. So for the cell values, the Xij value for a particular cell will be either 1 or it will be equal to 0. It is very, very important, right? And the objective of what, the objective of your assignment model is what? To minimize the total assignment cost, right? So the objective is to minimize the total assignment cost, or no, to maximize, it can be even maximize, to maximize the profit because of the assignment, because of the assignments to be done. Right, so this is very, very important, and this is very basic regarding your assignment model. Everyone should remember this, and you should understand this, because this is very important. Now, what will happen is that if you have we have seen that we will be having n by n matrix. So let's say that we have 10. The value of n is 10. Right. So if n is equal to 10. Morning only I've told you, if n is equal to 10, the number of possibilities that we have, number of possibilities for assignment. For assignment it will be what? For assignment will be equal to 10 factorial, and that particular value, if you do it on calculator, will be 36 lakh 28,800. So one way is what you will be manually testing all these combinations, and then you will be deciding the assignment. That can be done. It is possible, right? But it will be requiring a huge time. Lot of time will be invested, and hence there is need of an assignment model. Hence need of assignment model. You should always think why we are studying, right? So we have justified the need. So if there is 10, we are talking about only 10. The value of n is 10. So it is not very high value. We can have 10 tasks and 10 people to allocate those values. So it is a very normal normal number. N is equal to 10 is very practical, right? So if n is equal to 10, you will having 10 factorial, and this becomes very, very impractical to handle, right? So now hence there is need of a mathematical problem or a mathematical solution, which is called as an assignment model. So now we'll be doing what is the we'll be understanding what is the mathematical representation of assignment model. Mathematical representation of assignment model, similar to that of your transportation model. In transportation model also, when we have seen the started with the theory, we have done the mathematical representation of the transportation model. Here also we are going to see the mathematical representation of the assignment model. So let Xij denote the assignment of facility I to job J, such that what we can write, Xij is equal to 0 if I facility is not assigned to J, and it is equal to 1 if I facility is assigned to J, right? So it is that very clear. It is either 0 or 1. Therefore, the model can be given now as, the assignment model can be given as minimize Z is equal to I1 to n J 1 to n Cij into Xij. Very simple, right? So now here, particularly, what we have the constraints here. The constraints are subject to constraints. At that time, if you remember, we had constraints for supply and demand. So here also, particularly our constraint is so J value should be 1 to n is equal to 1. I is equal to 1, 2, 3 dash n. That is, one job is assigned to one facility. That is the constraint. One job is to be assigned to one facility only. So that is the constraint. And another constraint is what? Vice versa. One facility is to be assigned to only one facility will be assigned only one job. Right? So that is the reverse way, what we can write. So I is equal to 1 to n is equal to also 1, where J is equal to 1 to 3 dash n, right? For all this thing, one facility is assigned to jth job. So this is also one of the constraint, and we lastly have the constraint as xij is equal to 0 or 1, or even we can xij is equal to 0 or 1, right? So this is all the mathematical representation of your assignment model. I'm hoping that you will be understanding it is very, very simple. The actual representation is this, and then we have constraints, which is one job will have only one facility assigned, and one facility will have only one job assigned, and the value of xij will be equal to 0 or 1. So this is how this is your objective function, and lastly you have this constraints as well, right? So this is how this assignment model can be written, right? So